Good morning. My name is Osvaldo Bascur. I'll be providing this course with the internet group on September the 30th and the 1st. The theme is going to be digital transformation in the mining industries, concepts and best practices. I'm graduated from the University of Concepcion as a chemical engineer and metallurgical engineer. I work as a principal with OSB Digital, and I'm a consultant fellow for SIG Advanced Analytics. And we'll be looking at how to really implement these systems in the mining industry. Today, the digital transformation secrets, which are based on the book that we put together and is available in Amazon, if you want to look at it. We have too many data silos, microcultures. We have too many versions of the truth. There is a tremendous lack of information for management to make good decisions on how the minerals, which are changing drastically with lower copper grades today compared to the past, and how they need to assess what's going on. Usually the economic planning is flawed because it's not integrated with the capabilities of the plant and the type of minerals that we are dealing these days. There are too many opportunities today to redesign business processes. People can work from their home. They can contribute tremendously, irrespective from where they are today when we start using the cloud. Today as well, because you're using the cloud, you can take that data and transform it into information, which is what really models and people need. People don't need more data. They're inundated by data. What they need is insights that needs to be presented to them in a logical and informed way, and be able to store the knowledge that we are capturing in these online models. This is basically an example on how we have been able to implement this from the drilling to the recovery of water by managing the particle size distribution, on how these are being created and how we can manage the P80 and the specific energy consumption as we go through the plant. The technology that we are using on top of Pi, or other historians, as you can see here, is SIG, and SIG enables us to calculate the derivative, calculate and document the information that we are creating to present to management for their decision making and for operational maintenance, energy management, water management, and so on. There is so much data that needs to be treated correctly. We use the PI system here heavily to create a digital twin that I'm going to talk about and how we can transform that into really the better decision making. We have also a course that is longer that enables you to coach the team to create this digital twin model, to really assess the real hidden losses, create the modeling, and implement through the plant and hopefully through the corporation. The model is based upon the Goldratt theory of constraint, which has been automated for you to just plug it in and get it going. We will be able to talk about that in general and show you how we can calculate and estimate the water, the power consumption, the waste consumption as we go, and how to identify why flotation is not really happy when you start implementing a net metal production rate strategy. This is a plant, as you can see there. We use the models that have been developed over the years, and we create this rock processing and metal processing digital twin. As you can see, this is developed in Pi, and that data now becomes available to identify the hidden losses on the mine to mill strategy due to the ore type variation that we might have. We have the production losses, energy losses, water losses, and the overall effective production time, meaning how much the equipment has been reasonably operating in relationship with the capabilities and the condition of the equipment as well. So it's very interesting that you can have that documented for an asset production effectiveness. So that's how you are documenting, how you are creating those presentations and visualizations using Pi and the SIG Advanced Analytics. This is the typical problem, is that when we start maximizing the recovery, is not that very important. It is important, but the most important thing is to find an optimal economic grind cut. We don't call it P80 because it's not the P80. So we have developed a new way of doing that by using this new model learning, machine learning that enable us to find for the different type condition. As you can see here, the rate is changing and we are finding the P80 versus the recovery. So we can see that really what makes the maximum here is related to the way that we are managing the sump and the hydrocyclone. So those are the things that we like to convey to you on how we manage the hydrodynamics and the rheology of the plant. And here, as you can see here, how we can do this situation awareness, on-demand exploration, and third-party applications that run on top of PI, in this case, SIG Advanced Analytics, how we can do all this condition-based maintenance, how we model the plant, as you can see here, to identify all the mass balances and what amount of water, what are the site distribution that are being created in real time, how we use the new analytics and intelligence to develop these models, how these are created and developed and deployed. And here you can see we are going to look on how ArcelorMittal has been using some of these tools, how Barrigo has been using some of these tools, how Anglo-American started very early using this tool, and they're always improving as they go through time. This is me here. You can contact me if you have any questions, and we provide this coaching and implementation of your digital twin implementation. Thank you very much.